Hello, fellow data analyzers. Let's start another session on artificial neural network that is mostly focused on the R-based programming aspect. Today we are going to do what you see in this slide, data scaling with R. You already know why we need to do scaling. We have talked about this topic before, so later you can check the details you see in front of you. We have data normalization and also we have standardization. Both are possible, but this semester we continue with data normalization. In data normalization, everything would be between 0 and 1. We have talked about all these things before. With standardization, if you remember, things were between -1 and 1. And in a better words, the mean is 0. But we continue with data normalization. That quickly you can check the formula you see in front of you that we had it before. But the main question, how to normalize our data in R? Last session, we imported binary.csv into a data frame. Data frame is the main data structure that we use for analyzing our data in R. Check this syntax. Data.frames name, for example, the name imagine is data. Okay. When you put a dollar after that, in fact, you are telling R, give me the column that is named this, that comes exactly after that, from the table. So here you have the table, and here you have the column. The connection between these two things is with a dollar sign. So when you have the table, just put a dollar sign, and after that, the name of the column, everything would be easy. After that, the above syntax refers to the specific column of that specific data frame. I told you data frame is the most popular structure in R, especially when you are working with tables. For example, here the name of the table, dollar sign, and GPA is the title of the column. And the title, and you can find the titles of the column's title in the first row, in the header row. When you do that, when you get the column, the normalization of the table would be easy. Here, all the column of GRE, the whole GRE column is normalized. So it's another advantage of R that you see, we are not using for loop, while loop, or any of the things. When you put such a thing, data, that is the name of the table, column GRE minus minimum of that column. So minimum data dollar GRE is a column of GRE. Minimum of this column is just a number. Here we have a number. So another awesome aspect of R that makes it super easy is this. Here we have a column, we have an array, we have a vector, but you can subtract a number from an array. How it happens? For example, when you put 10, 3, it's a column, minus 2. In fact, R automatically convert this to this formulation, 2, 2. So it gets to 8, 1. That makes R super efficient for doing data mining, for doing data analysis. So here, with just this command, it gets all elements of column GRE subtracted from that number that is the minimum, and this similar things happens for denominator, and it is normalized. Let's do an activity to try all these things. Create a data frame by R based on binary.csv that holds the normalized values of the 3 input columns. Remember, my friends, we had GRE, we had GPA, and also we had rank. These 3 things are the inputs. Now here it asks you to normalize all the associated columns you have for this. Take your time, do it, and we will check it together. In the next slide, there is also the answer, so you can check if you have done it right, but take your time. Take your time and enjoy this much efficiency you can get from R. Just with a couple of lines, you can do such things. Also, you can see the process in front of you, but if you are okay, just continue your way. First, we get the data, read CSV, read.csv is the command for it. After that, the address. When I don't put that header through part, means that the first row is by default the header row. So I have now the data. Here is the formula for normalizing GRE. And you see, my friends, since I don't want to create a new table, I just replace the previous one. As you can see here, it says data $GRE. The new data $GRE equals to the older data $GRE minus the minimum over maximum over that. And finally, I get data GRE. So if at this time I get the table printed, as you can see in front of you, rank is not normalized, GPA is not normalized, but GRE is normalized. Because I replaced the old column with the new column. I didn't create them in a new table. Just to write a more efficient code with less capacity usage from the computer. Okay, after GRE, I go for GPA. The same formula, the same replacement, and I got this. And when I get the new print of the table, you see GPA is also normalized. The last part is about the rank. Data dollar rank, the column of rank in data. You see the interesting things about that, it just go about the titles. Well, maybe you ask yourself, okay, how it knows that the column name is rank. Check the data that you have given. There is a header. That's the point. You define header. And it goes and check. So it means it go and see all those equality formulation or syntax as we had with Java here, quickly like this. And when we do this, now it is ready. Data, and now all of them are normalized. Rank, GPA, and GRE. You can also check your answer with here, the formula here. Feel free to ask if you have any question. If not, let's go to the next one. Okay, what is the next? Now we have the data imported into R, and now we have the data normalized. What is the next step? Assuming that, given that we already have the neural network, what is the next step? Next step is to get the training data and testing data. So at this step, because we have all the data, we have all the data, okay? Now, the next things, we need to select out training data and testing data. Let me tell you here, our strategy, our policy is this. We are gonna select out 80% of this whole data as training data and the remaining 20% as testing data. Last semester, we talked about training and testing data a lot. But just as a quick review, training data is the data that you exactly train and run your model on them. So you give it the same question and you ask it the same question. But with the testing data, the neural network that you get from the previous part, you try to test them with the data you have here. So it makes the results more reliable. But the question is that, how to select out this 80% from the data? Now you have a table of 400 rows. How to select out 80% of this data as training data and how to select out 20% of them as testing data? To answer this, question, here we talked about that 80% and 20%. And to answer that question, that how we need to select out 80% of them, we need to first know about the vectors in R. It's again very easy. Vector of size k is coded like this in R. So then you always start it with C, open parentheses, and you put the elements of the vector you want to create. For example, A equal to C, open parentheses, 6, 8, 12 is considered a simple vector of size 3 in R. No need for defining the types and things like that. As you can see here, there are some examples. A is a vector, C, 1, 3, 4. And when we print A, it is printing it like this, 1, 3, 4. A structure of A, it says it has 3 columns, 1 to 3 columns, and the elements are 4. When you put character type, when you put string type of inputs in the vector, it is still capable of converting all of them to strings or characters, as you can see. When we print it, 1, 3, Montevello, 4. And when we ask about the structure, you see the structure is not numerical anymore. It is character. And it is 1 to 4, 1 to 3, 3, and like this. So now you know how to define and create a vector in R. The next step for doing that 80%, 20%, knowing about sampling in R. Check this syntax. Sample, open parentheses, X. X, here is the definition. The set from which to choose in the sampling process or a positive integer. It means you can put here in X, for example, if you put 3, 2, 5, 10. The sampling process it start to sample from this set randomly to 5 and 10. But if you put a positive integer, for example, you put 4, in fact, you are telling it to sample from this. The size is the number of items to choose from. For example, when here I put the size is 10. 10 is too much. It takes time to do that. Size, for example, is 4. Size is 4. Let's start random sampling. The first 5, 10, 5, 5 could be a sampling from this set of size 4. But remember, replacement was here. When I get 5 from this set, I replace it and again do the sampling. I get 10 because I have replaced 5. So in the third trial, I get it again. I got it again. What would happen if, and it is the next one, replace equal to false or true. When replace is false means as soon as you get an item out of a set, it is not available anymore in the set. But if replacement is true, it's possible that you can take 5, 10 times from that. So what happens if I have these things and size is 4 and replacement is, replace is false? What happens if I give R such a command? We have this set to select from and replace is false and size is 4, even more than the size of this set. Okay, it gives me error. That much simple. Makes sense. Another things, the last things is probability. If you don't put anything, it considers the probability equal. So when it wants to select between, or it wants to sample between 1 and 2 and 3, 4, it select all of them with equal probability. But you also can assign here a column for probability. This simplicity is really thrilling. Okay, for example, I put 20%, 10%, 0. What would be the last one? 70%, because the summation would be 100, but it also normalizes it. Even you don't need to care about that summation must be 1. It already normalizes it. And so it's gonna select it according to this probability. So with this sample, why we are talking about these things? Because we know at the next step with our neural network, we need to work on the selecting out the data for training. Data for training is 80% of the total data we have available. Why we don't train it on the all 100% training? Because we want to test it also with some data that we didn't use with training. So in that way, we would be more immune to overfitting, for example. Because when we see the performance with the training data is awesome, but the performance with the testing is terrible, okay, it means overfitting. So it means that the training has not been good. We have talked about all these things, especially when we discussed the chapter, the topic of trees last semester. So you can refer to that part for more and detailed explanation. Let's do some activities here to make sure you are good with this. Just for your reference, for your convenience, the syntax is provided at the slide, at the top of the slide. So do the activity 2, write a code in R that do sampling between number 1 and 4 10 times with equal probability. write a code in ART, the second part, that do sampling between number 1 and 4 10 times with the probabilities of the things that you see. Just before you started, for the first one, we expect to see equal number of 1s, 2, 3, and 4s. But here, since the probability of 1 is 90%, and for example, the probability of 4 is 0.05, so we want to see most of the items out of 10 items, elements are 1. Go ahead and check the results. Also, you can see the process in our presentation in front of you. For both of them, of course, replace must be true because the size of peaks is greater than the size of set itself. The size of set is 4. So when you are about to peak or sample 10 times, replacement must be true. For the first one, you see some sort of equal number of results. Some are 2, some are 3, some it happens, some is 1. But for the second one, of course, we expect to see 1 happens more. And the 1 happens here 80%, and 2 that here is 9% probability happens 2 times. So it means 20%. Makes sense. Let's go for the activity 3. According to all the points we discussed today, particularly R sampling, write the algorithm that generates training and testing data sets from binary.csv. Be advised, it doesn't need you to write the code. It just wants you to write the algorithm. The testing data is supposed to be 20% of the total data we have. So how you are going to do it based on what we have discussed. No need to write the code, but say, yeah, I'm going to do this, I'm going to do that to get the training and testing data. You already have 400 cases, you already have 400 observations. Out of these 400 observations, you want 80% random cases being assigned to training and the remaining 20% being assigned to testing. You may ask, is it possible to give the first 80% data, that is 320 cases, to the training data and the rest to the testing data? No, it's not possible. It absolutely must be random selection. So you make sure nothing like wrong entry, defected data, incorrect data is popping up in either training data or testing data, because it's possible. For example, for some reason, the data between 350 and 370 are all recorded wrongly. So if you want to assign all of them to testing data, that would ruin the testing data. But when you select everything randomly, okay, it's going to show up in both training and testing. So the total judgment, the general judgment over the performance of training would not get affected that much. Just try to give an algorithm for that. Try to get some sort of idea from what I'm writing on the slide in front of you. Okay, let's try together. Now let's try together. What we want to do is to assign randomly if this, for example, observation first, should be considered as training or testing. But also the total number of the rows for training, total cases selected for training equals to 320, and total cases selected for testing 80. how you are going to do that. Just talk about the algorithm. And then I will talk about my algorithm. There could be a bunch of algorithms designed for this purpose. I'm sure if I ask you to write the code with Java, you can do it quickly. But since at this point, we are not talking about the programming language, so just think about the algorithm. For example, how you decide observation 1 should be a training or testing. What about observation 2? What about observation 3? And like that. Just when you get your own idea, that would be good. Keep it for yourself. And after that, when I give you the way we do it, usually with R, you can experience a better training in this way. Okay, now let's discuss it together. When we want to do it, we create another column. And it is the way it is usually done by professionals with professional experience. Also, they use this method. They assign another column. And we call it testing or training or testing column. T used for training and S for testing. And here we start generating random numbers for the observation 1. We generate random numbers between 1 or 2. If it is 1, it is training. If it is 2, it is testing. 1, 1, and this is 2. So now we have another vector. This vector contains 400 elements. Each element is either 1 or 2. If it is 1, it says observation should be observation 1, or the associated observation should be in training, and otherwise it should be training. And also we know the number of ones is 320 and the number of twos is 80. But here, when we want to assign 1 or 2, how we assign it? 1 or 2, it's a random number. Random number, that 1 comes with 80% and 2 with 20%. That's it. So when we have such a thing, random numbers 1 and 2 with different probabilities, 80% and 20%. Now it should involve your mind that how to do it with R. We are going to talk about it in the coming activities. Question? But before we get to that part, how to get the length and width of a data frame in R? Because we have given our data to R. Now we want to get the lengths and widths. Just for your information, if this is your table, we have talked about this in Java. When we talked about two-dimensional arrays, we talked about lengths and widths. That's also the awesome part of learning Java. When you learn Java, you are ready for anything else. Okay, we call this as lengths, and we call this as widths. How to get the length of a data? It is the table that you have in R, and you put this command, n row, number of rows. It gives you the length of that table. Number of columns, n col, table in the parentheses, returns the width of the table. Now, activity 4, continue activity 3 by writing the corresponding R code. We have this one. So what does it mean? What you are supposed to do, you are supposed to create a vector. You are supposed to put in this vector 1 and 2, while 1 is being put over there with 80% probability and 2 with 20% probability. Take your time, try your best, no rush. It's the somehow critical thinking part of working with R. Make sure even by mistake, you don't check the answer in the next slide, because I want you to think about it. About that first, seeming complicated to define testing and training data based on that 80%, 20% rule. And now you are using R to do that. You need to create a vector. This vector only has 1 and 2. And the probability of an element is 1 is 80%, and the probability of an element being 2 is 20%. When you get it, in fact, you have that vector. So you can put that vector next to your table and continue with the rest. This is very efficient. How do you assign it to the table? I made the variable. It's the name of the table you have. Right. Oh yeah, that's the reason. Oh, right. Okay, this is the formula for these things. When you want to do such a thing, it is a simple sampling. In fact, you are sampling between 1 and 2 for 400 times, while replacement is allowable, and the probabilities associated with 1 and 2 are 80% and 20%. So when you do this sampling, you get these ones. You get these ones, and when you assign it to the table, you have exactly what observation as training and what observation as testing. For example, here it says that observation 1 is testing, training, training, testing, training, training, testing, and like this. In next session, we will discuss how we are going to use those things more directly regarding training our neural network. If you don't have any question, we are going to close this session. Okay. Have a great weekend. Bye-bye.